Hi, this is Chris, KD9CLH. Today's project is to build an UnUn, that is an unbalanced feed to an unbalanced feed, or an unbalanced feed to an unbalanced load. Its design is to provide like an isolation between, for our purposes, our transceiver and a wire antenna. This particular project is being done so that I can match what will be a random wire end fed, which will be put up on a mast that I am going to be purchasing very soon. For the purposes of this project, I have decided to use this design. Interesting thing about this particular design, this is going to be a 9-to-1 UnUn. Crazy thing is, when you look at all of the stuff on the internet, you find very, very few drawings that will actually depict a 9-to-1 UnUn. For example, if you look at the windings on this drawing, you'll find that it is an 8-to-1, and we can count them. Every time a wire goes through a core of a toroid is considered a turn. So you have 1, 2, 3, 4, 5, 6, 7, and 8. It's an 8-turn UnUn. However, whenever you look at the finished product, it does indeed show a 9-to-1 UnUn. I find this very interesting, and I think what happens is that the drawing is just done for reference purposes. I've seen them 10-to-1, I've seen them 8-to-1, I've seen them 11-to-1, and in some cases those designs are actually quite valid, which is one of the things that I'm going to be investigating. Now, one of the interesting things you'll find in this video is that this is being done by a complete neophyte. You watch some of the guys that wind these things and it looks very, very routine to them. This one is not going to be so much. It's going to be, you're going to see a guy who does not know what he's doing here. I've never built one before, and we'll see how it goes. Now, I have chosen for materials, if you'll bear with me here while I put all this kind of back together, because I'm using some of this stuff for my props here. And what we have here are a few toroids. What I'll do is I'll put them here. There are 4 of them here. I purchased 4 of them. These are, actually I purchased 5 of them. These are T240-43 toroids. It's a ferrite mix. One that I found to be quite favorable in everything I've seen for use in 9-to-1 UnUns. What you'll find here is that these are not coated like some of them that you see. In fact, they're pretty slippery. They're very smooth, and while they are of a reasonable size, get my fingers through here, they should be easy to work with, but we're going to find that out. These are, like I said, T240-43 toroids. 43 represents the iron mix. 2.4-inch outside diameter, 1.4-inch inside diameter, about a ½ an inch thick. And this one happens to be manufactured by Ferrite. And I found the 5-pack on Amazon for a decent price. The reason I'm buying so many of these things is that my intention is to not only build this particular UnUn today, but I also intend to build a 1-to-1 common mode rejecting isolation transformer for at the rig. Now, when you put together a 9-to-1 for an end-fed wire, you can use that in a number of ways. What you can do is you can mount the thing up at the top of the mast in which case you really would have to put some radials down to make it effective. But this one's going to go at the end, or at the bottom of the tower of the mast, and it'll be attached to a 450 ohm ladder line, which will run up the mast, and it will be then connected to the antenna. So it'll be matching 450 ohm unbalanced line, or balanced line, excuse me, to a 50 ohm coax. Now, some of the tips I picked up over time on these things is that I mentioned earlier that these things are pretty slick. And one of the tips that I did receive was to, in some of the videos I've seen, is to wrap it in friction tape. Gives it some tackiness, easier to work with. And you just use the same kind of old friction tape that you would use to wrap your hockey stick handle with when you were a kid, or tennis racket handle, or whatever you want to have a tacky grip on, baseball bat, you name it. I've also decided to take the hard way out here as far as wire material. Now, I have seen that what you can use in some of the videos, you can go ahead and use stranded wire. But the more you look into it, they say, yeah, you can use stranded wire, but you probably shouldn't. Now, I select these materials because my intention is to put that long wire up to be able to utilize 160 meters. And to do that, what you probably find you have to do, if you'll excuse the focus here, is that you have to use, thicker materials, or you should probably use thicker materials. This is 400. This is number 14 Romex cable, solid wire. They recommend the use of solid wire because it'll help you give you some broadband. And I use the heavier gauge stuff because it will help me with that lower frequency. The same applies to using the larger diameter core, I am led to understand. Whether that's true or not, we'll find out. I've also, what you see here is kind of put a little bit of tape around here to kind of hold this trifilar stretch of wire together while I actually do the winding. So there are the materials. And in the next section of this video, what you'll actually see is a higher wire act as KD9CLH actually tries to wind this beast. So bear with me. Okay, so here we are. We have our materials in order here. And what you'll notice, what I did in preparation for doing this winding, is I did label these wires somewhat. What I've done is I have put a marker, one tick, 2 tick, 3 tick on the wires to kind of keep them in order as far as identifying them. But what I am finding already is that despite the fact that I have added these pieces of tape on here to kind of keep them in alignment, it's not doing the trick. So as I do this winding, it's going to be the first challenge, to wind this fairly heavy, non-malleable, solid copper wire through the toroid core. But keeping those trifilar windings in the proper sequence as well. So let's see what we can do here. What I have are some very colorful tie wraps here that I will use to try and keep these things in place, these wires in place as I go through. Now the object is to begin on the left side of the toroid and go in through the top like this. Then what we will do is we will bend this around, and it is a challenge, folks. As I said, this is going to be kind of a high wire kind of thing, if you'll excuse a pun. But it's going to be a challenge now to kind of keep these things wrapped tightly and in sequence as we find our way around this toroid. And there we have our first winding. Now, one of the videos I have seen was done by a German gentleman, and he seemed to be of the opinion that it was very important to maintain a 6mm spacing between the individual wires as you find your way around the toroid. He was working with thinner gauge wire for one thing. We're working with the 14 here, and it does have its insulation on it, which is going to provide some of that spacing on its own. 6mm, probably not. But what we're going to find here, based on some of the other videos I've seen, I hope we're going to find here that that isn't quite as critical as what that gentleman made it out to be. So we will continue. We'll proceed. As you can see, these guys are all kind of slipping here, so their usefulness is brought into question now as to whether it's really necessary or even possible to even have them. Maybe I just didn't use a proper kind of tape. I used the friction tape, and I began to see that would have been probably more appropriate had I used instead a regular vinyl tape on the wires themselves to keep them in that sequence. But challenge accepted. We're going to try and keep them in line. We now have 1, 2, 3 windings. 1, 2, 3. So we're a third of the way here, there now, as far as getting this bad boy wound up. And again, it is a challenge to keep these wires in the proper sequence. But so far, it appears so good. We're going to go for number 4. Again, very challenging to maintain that wire sequence. Using this pretty stiff wire. Again, inspect it each step of the way. Make sure you're maintaining the intended 1, 2, 3 sequence of the trifilar winding. Okay, one thing I'm learning here as we do this for the first time is that with this heavier wire on this core, it probably isn't all that critical to use these ties, because at least initially it appears to be holding fairly tight. Now what I'm going to probably have to do when I finish here is to tighten this all up around here and make sure it lies very flat and as evenly spaced as possible along the way. It may have to involve actually rewinding or making some kind of an adjustment on this. By the way, I chose a 40-inch length of wire, which may be making this, contributing to the difficulty here as we make our way around. But that's 1, 2, 3, 4, 5 windings. Getting ready to do number 6. There is the 6th winding. Again, doing everything we can to maintain a proper sequence of these 3 windings, from which it gets its 9-to-1 name from. One, 2, 3, 4, 5, 6, 7, and the finding here is that we may come up short, or we may come up right on the money as far as how much room we have on this toroid to wrap number 14 insulated Romex wire on. As you can see, it would appear that this tape maybe even be getting in the way. So 1, 2, 3, 4, 5, 6, 7, 8, and we will get ready for our drum roll here as we prepare to do our last winding through the toroid. I'm sure that this is coming in and out of focus here because what I am doing is I am facing away from the old Kindle here, the fire, as I video this, so I cannot see what this video looks like right now. And when we do the edit, we may actually dispose of it and make another attempt after that for clarity purposes. But let me see here if I can find, there it is. Very difficult, much more difficult than I thought it would be to keep these in line because of the unworkability of these very stiff number 14 Romex type of wires. So there we have it. 1, 2, 3, 4, 5, 6, 7, 8, 9 windings. First one going in over the top, second one coming underneath, and I do believe I have been able to maintain my 1, 2, 3, 1, 2, 1, 2, 3. I will confirm that by use of a voltmeter, and we'll see how that goes. Now this is going to be a work in progress, this video. I'm putting it together for the benefit of those of you on 100 watts and a wire, so that what we can do is follow the travails of someone who does not know what in the heck he's doing and is only trying to learn what in the heck he's doing by watching the pros do it, and then try to execute on his own. Now, what we'll be doing with this is, off camera, is we will go through and rework this a little bit to make sure that we do have as uniform spacing between these windings, make it look as nice as possible, make sure it's anchored down very well. We'll do continuity checks 1, 2, 3 to make sure they're all set. I will make the proper connections as shown on the diagram here to get the thing prepared to install into a small box that I have ordered, and it will be here in the coming days. With any luck, within the next couple of weeks, we'll actually be able to complete this little project when we have all of our parts and get it installed in a box and get all the soldering done, get all the checks taken care of. Furthermore, from here on, the intention is to purchase in the coming days a Fox Delta or Delta Fox, I forget what the name of the, I think it's a Fox Delta antenna analyzer kit. We will get a 450 ohm resistor to use as a mock antenna. We will run this toroid 9-to-1 UnUn toroid auto transformer through its paces to see how it performs across a band from about 1 to 30 megahertz. And then later on in the spring, it is now April the 9th, I believe, and there's April the 8th. We will hopefully by the end of mid-May or end of May have the tower or the mast in place and prepare to put up our push-up antenna, our push-up mast, and then attach the antenna at the top, run some 450 ohm ladder line down to the bottom to a box containing this 9-to-1 UnUn, and then see how it works with the rig. Now, one of the other things I am going to try to do, and I really have my doubts about this having done this now, is to do 10-to-1 UnUn. I may or may not have room to do that. But the reason I would consider doing a 10 or even an 11-to-1 UnUn is to provide even more bandwidth down on the bottom end of the long wire's capabilities. I don't care too much about the top end because I do have an off-center fed dipole that works just fine. The hope is that I can get better performance on 80 and especially some access to 160. Thus my concern with actually providing a better performance down on that bottom end, because right now I have virtually no access to 160 with that off-center fed, which has been cut for 80 meters because that's how much room I've got, guys and gals. So that's it. That's a more or less successful first attempt at winding a 9-to-1 UnUn using heavy Romex wire, and we'll keep you posted on our progress. Until we have a chance to do that, this is Chris, KD9CLH. Clear. Okay, we're back again. First off, let me apologize for that segment on winding that 9-to-1 UnUn that you see down on the bench here. It turned out to be as much of a shadow puppet show as a winding, but I think we obtained our objective. We showed you know, that it's not a difficult proposition to wind a 9-to-1 UnUn unless you select materials that are going to make it tough on you, as I did, particularly in that Romex 14 gauge solid copper wire. But be that as it may, I'm pretty happy right now because what we did is we did a very close inspection of the windings to be sure that they did in fact stay in line. Nobody jumped the track as we were doing the winding there. The A1, B1, C1 wire stayed in sequence with the A2, B2, and C2 wire, and we confirmed that after checking the tracking through the toroid, the 9 coils through the toroid. We confirmed that by use of a voltmeter, or a VOM, excuse me, an ohm meter, to check for continuity between the proper wires. So happiness abounds here. That looks good. What we did do after that is we did proceed to do some of the intermediate connections here. The two in mind were the C1, which is the end of that set that came from the bottom, to the, from the B1 that came from the middle of that top set down to the A wire of the bottom set. We stripped those wires appropriately. We scraped the enamel off from the wires, and then we soldered them, crimped them, and soldered them together with kind of the old lineman's loop and hook arrangement, and then soldered them. So that one looks very good. We then proceeded then to cut the B2 wire down to size, strip that, cleaned its end up, scraped the enamel off, and put the hook in, and then scraped a piece of the insulation off from the middle of this C1 line that will go to the coax connector, the PL259, and we cleaned that up as well and made that solder connection. So we have UnUn. Happy about that. Very happy about that. Trust me, if I can do it, pretty much anybody can do it. Like I said, this was an attempt to show that someone who doesn't know what the heck he's doing can figure out what the heck he's doing. And I think we succeeded in that. What we will do now is we'll wait until we get our box in. When we do get the box in, we will do the proper drillings to run a stud through the side or through one wall of the panel to provide a connection to the 450 ohm wire, which will go up, 450 ohm ladder line, which will go up to the antenna. We will also install PL259 and connect the ground to everything there as well. So happiness abounds here. Happiness abounds. Once we get that thing put together, we will, and we have our antenna analyzer, we'll put a 450 ohm resistor across this ground and this 450 ohm connection, and run a signal into there, and make sure that we do have a decent flat line, or a reasonably flat line from 1 to 30 megahertz using the antenna analyzer. So I think it's been a good afternoon here. A good afternoon to learn how to wind an UnUn, how to put it together, and we'll get to do some experimenting. So until we get that panel in place and get to put this bad boy in there and test it out, this is Chris, KD9CLH, clear.